Alright, so today I want to discuss manual T a little bit. Manual T is all about proper diffuser selection and placement. So the whole idea with manual T is so that after you're done with the design of a house, you can try and figure out, okay, where do you want diffusers, how big should they be, and where do you want to place them. So once you place the diffusers, you can do a duct design. So really the process goes manual J, manual S, manual T, then manual D. But I usually skip S and teach about T first, only because it kind of breaks stuff up from all the math. And it'll teach you a lot about walking into a house and kind of understanding why it might have some problems. So with that in mind, let's just talk about it a little bit. So this is my little packet on manual T basically. And manual T is one of those ACA books that I actually don't really recommend you buy unless you really just want to, have it to have read it. Because most of the information that I cover in manual T is most of what you're going to learn out of it. It's not a very big book and it's not a very expensive book. So if you enjoy looking through ACA manuals, I would highly suggest, you can buy it, but at the same time, by the time we go through this little short thing on it, you'll understand most of what's in there. Okay? So, you can see here what I got written is, the goal of manual T is to discuss proper diffuser selection and maintain human comfort throughout a room. All right, it's important to note that the load calculation and duct calculations has to be done properly for the diffuser selection to be correct, but diffuser selection is commonly overlooked. We will see why this is important. However, to clarify comfort, look at the following graphs. Okay, so here's an ASHRAE standard occupant comfort goal chart, and it tells you what is commonly considered a comfortable area for people. And then there's a couple more things here, right? There's some more stuff you can look over. But the main thing is, and I kind of like this psychrometric chart, but let's talk about this first. The main thing you get out of this is from floor level to 66 inches. So from floor level to about 5 foot, which is about head height, 5.5 feet, right? You can have up to a 5.4 degree difference between the floor and head height. That is normal. So people almost never check it, right? They don't actually check what the temperature difference is up, but you're allowed to have that much temperature difference between the floor and head height. But that's the most that's the most difference you should have, is around 5 degrees. If it's more than 5 degrees, then you're probably not moving air in the room well, right? Because that's a sign that we're not mixing the air, which is the total purpose of properly selecting diffusers. As far as temperatures and humidity go, I kind of like this chart a little bit better. This is closer to correct if you were to ask me based on what I see temperatures at with people and things like that. And that is the comfort zone for people tends to be between 68 degrees Fahrenheit to 78 degrees Fahrenheit, and the humidity at which they're comfortable is between 20 and 80%. You get over 80%, under 20% humidity, you get below 68, above 78, people tend to be uncomfortable. And they're going to be comfortable in cooler temperatures during the winter months and in warmer temperatures during the summer months, because your body's kind of already acclimated to that. So the lower ends of these spectrums is winter temperatures and the upper end of these spectrums is summer temperatures. Now granted, everybody's different. Some people find comfort at different temperatures, but in general, these are kind of your range. And obviously the closer you are to the middle of the range, the better. 72 to 74 is ideal, 50% humidity is ideal, but our goal is to keep as much of the house or building as possible within the comfort zone, including that allowance we have on temperature between floor to 5'6". All right. Understand that in the end, our goal is to provide a room where the entire occupied zone is in the comfort zone with as little stratification as possible, with noise criteria and acceptable levels, without creating movement that is air movement which is too fast within the occupied zone. So to discuss that last bit first, if the air movement is too fast, especially in winter months, people tend to feel uncomfortable. They feel like they feel a draft. So I've had multiple cases in office buildings where people will say that it's too cold in a room, and it's not really too cold in the room. They're comfortable at the temperature, but they can feel the air blowing across them, and that's what makes them uncomfortable. So it's a very important question to ask sometimes. Can you feel the air moving? Does it feel like you feel a draft? Because people perceive it as a draft, but really it's just the air moving too fast at a diffuser, hitting at a crappy angle, and especially women with exposed legs in the winter, if they're wearing a skirt or something like that. You're very sensitive on your ankle areas to air movement. You're very sensitive to air movement around your neck. Those things will make people feel uncomfortable when the temperature's good. So all of these highlighted and in italics words are definitions you should understand, and we're going to go through basically all of these. We already covered comfort zone a little bit. Comfort zone is this area, so when we talk about comfort zone, this is our comfort zone. So we're trying to keep everything within the comfort zone. 80% humidity, 68 to 78 degrees. The occupied zone we'll go over shortly, and then stratification and noise criteria we'll also understand. But this is our goal basically. Our goal is to make sure we understand everything that's being said in this whole sentence. By the time we're finished reading everything, you should understand the best methods of achieving these goals, and on the climate the house is located in, because that's important. Where the house is makes a big difference on where the best placement of diffusers is, and that's what we're going to go over. Alright, so real quick first, stratification is the difference in room air temperature throughout a room, generally from floor level to the top of the occupied zone. Again, floor level, top of the occupied zone, which is 5'6", really 6 feet. Top of the occupied zone is 6 feet. So floor level to 6 feet is the top and bottom of the occupied zone, and we'll talk about the sides of it. But stratification is the air temperature difference from the bottom to the top. And like we said, we want to keep that 5.4 degrees or less, 3 degrees Celsius or less. Basically 5 degrees or less, right? So the top of the occupied zone is usually going to be warmer, the bottom is going to be colder. We don't want more than 5 degrees difference, and if there's a lot of like different air temperatures from top to bottom, that's called stratification. So we want as little stratification as possible. We want as much of the room air to be even as possible, and that can be very difficult with forced warm air heating or cooling sometimes. Radiant systems tend to do a little bit better in those situations, but it can be done with proper design. So that is stratification. Stratification is the differences in between temperature top to bottom in a room. Alright. Do I want to do that next? Yeah. Let's just talk about this page next real quick. So we talked about stratification. Like I said, there's some little highlights on different temperature areas here, but it's not that important. Alright, so purpose of Manual T is to provide basic guidance on selection of installation of supplied diffuser and return outlets. We will cover the basics of Manual T here. First, we have to understand the different supply outlet and return types. These are grills. A grill is a fixed opening through which air passes, typically used for return air applications. So, a grill is just a grill. It's got louvers on it to, cover up the opening, basically, to make it aesthetically pleasing. But it's just basically an open hole. It's just a grill covering an open hole. All right, a register is a grill equipped with a damper that supplies room-conditioned air, typically used for supply air applications. So a register with a damper equipped is a register. So that's what we usually see in houses, right, is registers. And then diffusers is an airflow device designed to discharge conditioned air in a specific path, direction, or pattern, and used for supply air applications. And we think about diffusers usually as commercial. The commercial ceilings have diffusers in them. Ceiling diffusers. So a ceiling diffuser is going to spread air out in multiple directions sometimes. A register is usually just going to be one or two directions that the air is going to move. So we want to place these in the optimal locations to promote mixing of room air and to prevent stratification as much as possible. The optimal location is going to change based on climate, okay? So depending on our climate, the optimal location for these diffusers can change. And depending on what floor of the house you're on, the optimal location can change. And we'll talk a little bit about that. But remember, these rules don't work everywhere. All right? It's going to change based on our climate, based on our house design, and a couple other factors. So first let's discuss returns, because these are the easiest. Returns are the easiest thing to figure out where to place. People overcomplicate return placement way too much. All right. First thing to remember is return location is generally not very important. It is not the most important thing to think about. If you think there's an issue in the house that's related to the return other than it's probably too small, it's probably not the return that's the issue. But there are a couple of things that could cause problems, right? Returns generally only affect air movement within 2 feet of its location. So, again, the air is not going to move better because of where you placed the return most of the time. It's not going to have a huge effect. But this does mean that the return should never, ever, ever be placed within 2 feet of the supply outlet. And really, the rule is within a couple duct diameters. But to simplify it, 2 to 4 feet from a return, you should not have a supply, period. There should be no supplies anywhere close to a return, because the air will short cycle from the supply straight into the return, and it won't mix the air in the room. So you always keep, you generally place returns opposite the supply, right? Just to make it easy. So, if your supply is over on that side of the room, then you place the return over on the other side of the room. A lot of people will always place the return near the floor if the supplies are in the ceiling. That's not really critical, but you do want to keep, generally for our area, you want to keep returns center or inside wall of a room and supplies on outside walls of a room near windows. But basically, you just wanted a good distance from the supply. Best location is generally opposite. We just talked about that. Each room needs a return back to the equipment. Generally, they should be kept away from kitchens and bathrooms or where unwanted smells will be circulated through the system. Single, centrally located returns are not recommended by ACA, and neither are door undercuts for returns. All right, so we'll talk about that more when we get to Manual D, but to simplify it for now, every room needs a return, okay? That means every room with a closable door. So, a master bedroom should have a return. Individual bedrooms should have returns. If there's anywhere you can shut offices with a door that can be shut, should have returns. As long as it's open to the rest of the house, one return is fine. But if there's any door that you can close so that air does not move freely, then you need a separate return for that room. I know a lot of people don't follow that. It's becoming way more common for people to, at least like on upper floors, they'll do one central return and at least one return in the master bedroom. That usually works out okay. But in general, you should have a return for every room area with a closable door. All right. And we'll talk about door undercuts later. Finally, returns tend to be noisy. The face velocity of a return grill should be kept to 350 feet per minute to prevent unwanted noise. Additionally, the return should not be in direct sight of the equipment, and return transfers should have offsets to prevent noise transmission. So that's probably your most important thing about returns is preventing noise. So if you have an issue where the return is noisy, there's a couple things you can do to mitigate that. The best thing is to avoid situations like this, right? This is bad because the return is going to right next to the equipment. It's going to be very noisy right there. Ideally, you want to return with a couple offsets like this. All right, you want a couple offsets there so that this will help mitigate the noise. If you've got a transfer grill, so if you've got another wall right here, so if we were to picture a wall, you know, if we had another wall here and we were just separating two rooms, all right, you know, if this was a wall and we were separating two rooms, then you would want to do the same thing, because a straight return between two walls like this over here, right, straight return between two walls like that is gonna transfer noise. So if you need to do a transfer grill, it's better to have two elbows so that you can mitigate the noise transmission from room to room. It's especially important on rooms where you want privacy, you know, office spaces in the conference room. You want to have elbows on the transfer, things like that. You know, if you use a transfer grill as a return for a master bedroom or something, you're probably going to want a couple elbows on that. You know, usually you'll end up going from ceiling to ceiling on the return, so you have to make a 180-degree turn. 180 degrees is a good point to mitigate noise. Alright, so that's our most important thing with returns. You should remember to mitigate face velocity. We'll talk about face velocity and how to calculate that with manual D stuff. But you want a low face velocity, preferably 300 feet per minute or less, but 350 feet per minute is good enough. Return should not be in direct side of the equipment, and return transfers should have offsets. Alright, those are the most important things. And the fact that the return should never be placed within 2 feet of supply outlet. If you remember anything about returns, I want you to remember that. Everything else really doesn't matter. Oh, and let me, you know, keep them away from kitchens and bathrooms. Alright, you don't want to return in a bathroom. I know I said every room should have a return if it's got a closable door. A bathroom is not one of them. Okay? So those highlighted portions, not within 2 feet of the equipment, kept away from kitchen and bathrooms, face velocity of 350 feet per minute or less, returns not in direct side of the equipment, return transfers should have offsets. Supply outlet location's a little bit more tricky. Alright, you gotta think, you really need to think about supply outlets. Just to dispel something real quick now, a lot of people will say you can make a duct too big, right? They'll tell you in houses, you don't want the duct to be too big because you won't have enough velocity in the duct, and you want to be able to throw the air when it gets to a diffuser. That's a load of crap. The problem is if you don't pick the diffuser properly. As long as you select a good diffuser, you really cannot oversize the duct going to a diffuser. But if you oversize a diffuser, you're never going to get good airflow. It doesn't matter how big your duct is. Alright? So if you're ever designing a house, you need to think about what diffusers you're going to use and how big they're going to be. It's extremely important, because if you get that wrong, everything else can be good. But if the diffusers are too small, or the registers are too small, or they're not in a good location, everything else is going to go to shit. It doesn't really matter, because where the rubber meets the road, where the air meets the room, if it's no good, doesn't matter how good the rest of your design is. So for our area, for our climate, long windows and outside walls is ideal, and that's what we usually see in that area, but not always. We don't always see long windows and outside walls, and I can attest to how uncomfortable it not being in these locations can be, especially in the winter. But long windows and outside walls is ideal, okay, for our climate. And we'll talk about what's good in other climates when we get there, but for our area, we want supply outlets along windows and outside walls, and typically what I say is one for every window. You want one diffuser for every window, and then if you got a big double window, one diffuser is fine for that too. But basically, every glass opening in the house, you should have a diffuser. And then if you need more, stick it on an outside wall with a lot of exposure to the outside as you need it. You know what I mean? You can add more after that, but typically I just start at every single window. So generally this is going to be a floor outlet when possible, but ceiling outlets are acceptable as well where necessary. It really doesn't matter. Floor, ceiling, both works fine. Diffusion registers should be point straight up or down to allow the air to create a draft barrier against the windows, preventing the feeling of cold air entering the home. And I noticed that sentence. Okay. One, remember draft barrier. Sometimes little electric heaters are called draft barriers because that's their purpose, to prevent a draft from the window. But the draft is not actually the cold air entering the home. All right, actually I didn't state that well. The draft is not really the cold air entering the home. The draft is the hot air exiting the home. So the warm air is usually traveling to the window because heat goes from greater concentration to lesser concentration, right? So the heat in your house is trying to escape to the outside. It wants to get outside because it's colder outside than inside. So as the heat's trying to escape, you can have some pretty quick air movement as that heat moves, and people will perceive it as a draft, but it's usually not cold air entering. It is heat exiting. Okay, so it's the feeling of cold air entering the home, but the actual situation is the warm air getting out of the home. All right, and that's obviously winter. Now in summer, it's heat getting in, right? The heat always is what's moving. This is the optimal location for our climate and any other climate that is considered more heating dependent than cooling dependent. So if you have more heating days than cooling days, this is where you want them. So I'd say we're right in the middle of heating days and cooling days for the most part, but we're still more of a heating dependent climate. So along windows and outside walls is generally the best placement for our area. This is also the best location for baseboard heaters where possible, although directly below doors is not recommended. Directly above doors is a suitable location. Note that a single outlet directly above a door or window is more effective than two outlets on either side of a door or window. So anytime you can place that register center of the window, one register, that will always work better than two, one on each side. So if you need more CFM, say you need 150 CFM. Generally, I try not to do more than 100 CFM per register, okay? So if you got to do more than 100 CFM, then I would split that up into two. If there's a big double window in the room, then I'll probably split, one register on basically each side of the window where it's aesthetically nice, okay, where it looks nice in the room. But if I need 100 CFM, and I got a choice of 280 CFM diffusers or the 100 CFM center of the window, I'm generally going to go with that 100 CFM center of the window.